Again, I'm Emmeline Pat Dahlstrom, and this is Eric. We're from Space Base, and we're delivering the Space for Planet Earth Challenge this year. So before I turn you over to Eric and Martin, just to give you a little bit of an agenda for tonight. So we're doing this as an informal session. Really, the focus is to, if you have any questions about the challenge, we'll spend like half of the session, the 1 hour session on Q&A. But for the first 30 minutes, Eric will talk a little bit more about the motivations of the challenge and then also the technology. And then Martin will talk more about the problem and specifically blue carbon. And then just to note that this is a first of 3 sessions that we're doing. And for this particular session, we're, I guess, more focused on carbon sequestration. And then the next one on the 7th of September, we actually will focus on coral health. So those are all I need to say. And then I'll turn it over to Eric and we will start share.
All right. Yeah, so we're talking about our Space for Planet Earth Challenge, and Emmeline will later on will be talking about the details of how to get into the challenge and the timeline and everything else. But basically, this is the overall challenge is about climate change, and as we all know that Earth is in a climate emergency, and emphasized by the release of the IPCC report yesterday. But a lot of times people are trying to figure out what they can do about this, and we feel that this challenge is to highlight what people both as high school students or university students or startups can take an active part and address some aspects of climate change using the power of satellite data. So a big part of the transformation in the last decade that enables this is the exponential technology, which has transformed computing and also the delivery of satellite data. Long ago, when I started with working on NASA satellite data, we used to have to spend $100,000 per person that was good at analyzing the data because you need specialized hardware and specialized software. And now that your laptop and free software enables you to do this. And so that's the opportunity where our message of this challenge is that people now can participate and be involved in addressing climate change. So we have 2 categories. Emmeline will go into the details later, but first, in the high school category, we're focused on coral health in the Pacific region. And the problem statement we have is help improve the monitoring of coral health changes due to climate change using satellite technology. And the reason we've chosen this is there's an important resource called the Allen Coral Atlas that uses planet data to monitor the health of coral and applies very broad machine learning algorithms to the state of coral, but they are looking for people to help improve the atlas, help apply it in various different kinds of tools and problems. And we'll have another session where we talk just about ideas about how you might use the atlas and improve it. But the atlas itself has data training and references and is very user-friendly for getting into it. There's so allencoralatlas.org is the access for that. The other area in the university startup category is carbon sequestration. How much carbon is being stored in various kinds of material and land in the coastal areas. And so this problem statement says, using satellite data in combination with other data sources, help develop verifiable methods to measure carbon sequestration on land or in coastal areas. And so we're keeping these problem statements broad so that we can encourage people to try different approaches to attack different aspects of the problem and use different tools and techniques. And so some of the details of this, the different land and coastal areas include forest, native bush, pastures, wetlands, coastal zones. And the potential data that can be applied is our partner in this challenge, Planet, is providing special Planet data for the team members. But there's all sorts of other data sources that teams might consider using, from ground truth to Sentinel-2 multispectral data, Sentinel-1 radar data, and various kinds of laser LiDAR data. And I'll talk a little bit more about that. But the different aspects of the problem are everything from it can be as simple as monitoring the extent of forested areas, or as you get more challenging, how much carbon is being sequestered in native bush. That's a very challenging issue. And then there's some research indications that you might be able to detect how much carbon is being sequestered in pastures, depending on how pastures are managed. And it's almost at the boundary of what's possible with this data, especially because so much of the carbon is being sequestered in the root systems underground. So we have sort of a current state of the art. New Zealand is monitoring, basically has a report on an international reporting basis of their estimate of carbon being sequestered across the country. And they basically use Sentinel-2 and Landsat low resolution data, and they combine it with a lot of a ground truth sampling from measuring certain spots in both soil and forested areas. But it's appropriate for a national level, but it doesn't. It's completely too low resolution for landowners, and it's in fact the emission trading scheme and carbon credits and that New Zealand has established really depends on a lot of ground truth going out and sampling trees in forest blocks. So with this challenge, we have Planet data with visual light and near infrared with 5,000 square kilometers in blocks for the team. And so that's opportunity. There may be more information in the free Sentinel multispectral data in the visible and infrared bands that you might try to mix in. And then there are other sources from the laser LiDAR can measure, the heights from of the trees and the canopy down to the ground. The microwave can tell you something about what the condition of the soil, and the radar penetrates also into the soil somewhat.
Yeah, so I think we go on to the next part of the session. Is I just want to introduce to you Martin, who is a climate scientist, physicist, and then technology engineer and entrepreneur. He has worked on several world first innovations, including the first portable computer, first desktop server, first CRM. He's now the CEO of the Northlands Innovation Center, an applied research lab addressing core technical and business challenges in renewable energy, sustainable farming, and small transport. He's talking to us today about blue carbon and how it could address climate change challenges. Welcome, Martin.
Thank you very much. Thank you very much. I thought of starting with a little me. So, kia ora koutou. ko kala aston te maunga, ke sopase te awa, no te oa hema ahau, ko Helmut Rava, ko Gertrud Oku Matua, ko Martin Toko Ingoa. Nora Rai. Thank you very much. And yeah, thanks very much for joining us this evening. So thanks for the introduction, and I'm quite chuffed to be able to talk about the interaction between the ocean and what we could observe from space. And as some of you may know, the Intergovernmental Panel for Climate Change has released a new report, I think this week. So it's quite challenging environment. And I just want to talk a little bit about the role of the ocean and innovation in the ocean. So since I come from a landlocked place, which has got about 600 kilometers of coastline, I always craved for the ocean. And I'm now living here in probably one of the nicest places on the planet, on the Tutukaka coast in Northlands. And some of those images were supplied by one of my colleagues who does a lot of diving here. So this is not made up stuff. This is actually happening right where we live. So about 20 minutes from where we live.
Martin, you need to start sharing again. I'm sorry.
Oh, sorry. Ah, okay. I was looking at my screen. Sorry.
Sorry.
Okay. Can you see the screens now?
Oh,
Yes, perfect.
Okay. So, and yeah, so this is a pretty amazing environment we live in. And whoops, how do I flip? Here we go. Okay, so what we're currently looking at is I'm currently the co-chair of the New Zealand Marine Energy Association called Aotearoa. And we're trying to establish with government that we can get about 50 square kilometers of, we call it Sandpit or test area, where we can test innovation, blue ocean innovation. So that's around energy from the ocean, that's marine permaculture, that's producing portable water from the ocean, and carbon sequestration. So on this chart here on the right, you see some of the tidal and wave resources. So the west coast of the North Island and the South Island are probably some of the best resources in terms of wave energy on the planet. And then, of course, the Cook Strait has got both tidal and wave energy. And anyone who was in Wellington over the last weekend knows how fierce and wild it can be. I think they measured freak waves up to 8 meters. So it's a pretty hostile environment, but there have been some estimates that there's about one or over several gigawatts of energy which could be produced from the ocean in New Zealand alone. And here in Northland, we're very privileged. We have several harbors which lend itself really well for marine energy generation. And apparently there's a big project to establish an offshore mussel farm in the Bay of Plenty. So I think it's in the several $100 million project. So, and again, if you operating a big marine permaculture facility offshore in huge waves, you want to have as few people on the site as possible. So there's a lot of room for automation, for harvesting and other things. Here are a couple of use cases for blue ocean areas. So here on the left, it's energy production. So this is a tidal energy turbine. So it has been invented by, I think he's called the father of wind energy in the United States. It's a guy called Jim Delson. So he, for the last 40 years, developed wind energy systems in the United States, was knighted in Denmark for his contribution to Vestas, which is, I believe, the biggest wind energy producer. And 10 years ago, he started to develop devices to harness the power of the Gulf Stream, Kuroshio, and other currents. And it's essentially an upside down wind turbine. Down here, you see a much smaller scale device, which basically uses the pitch and roll of a buoy to generate enough energy to do ocean observations. So it's water quality, water temperature, turbidity, that kind of stuff. And again, there's a lot of stuff which could be complemented by observations from satellite. And moving on here, of course, the energy generated from wave or tidal energy could be used to make coastal communities more resilient, power hospitals, schools, and other key facilities. And it could be a hybrid of marine resources, solar, wind, and other things. And then here's a really important part. A lot of the island states, or even some of the remote coastal communities, have got water issues. And if you had a look at the IPCC report, and I go over the key things a little later on, is a big chunk of the challenges in the future will not be about energy, but will be about potable water. And we think generating potable water from ocean resources is one area where I think New Zealand can contribute. Aquaculture, I briefly talked about it. You probably have heard of blue data centers, or if you haven't, again, this guy I mentioned before was the first who ran a blue data or underwater data center for Microsoft a few years back. Essentially, the reason why this is of interest is about 5% of all the electricity in the United States produced and used is used for data centers, so powering computers and cooling computers. If you put computers into colder ambient temperature and then actually have a coolant, i.e. seawater, you can run a data center at much higher efficiencies. So again, this is something what we are aiming to research further about. Carbon sequestration, I come to that a little bit later. So there's natural ways for carbon sequestration. Whales, for example, are called I think the carbon pump. So they bring nutrients from the very bottom of the ocean to the top of the ocean, and then help to spawn a lot of flora and fauna in the ocean. Here in Northland, we have a really cool company called, what are they called? Freightfish, I think. What they're doing is they're trying to innovate how we transport stuff on the ocean. I don't know if you know, but most of the container ships and freight transported over the ocean is using some of the most terrible fuels you can imagine. So the environmental impact of ocean-based freight is massive. And I think from next year onwards, new year regulations are coming in. And this company is actually using some of the technology which has been developed for the America's Cup, i.e. foiling on boats, to foil single containers in big ports. So often in ports, there's this issue that if you want to transport a container from one part of the port to the other part of a big port like Hong Kong, Singapore, you need to wait till the next ship comes along. So these guys have the idea that you can ship individual containers using foiling technology where you need less energy. And next to it is the East-West ferry from Wellington. So that has been designed here in Whangarei. And it's an electric ferry. So that basically uses electricity to propel the ship forward. From everything over 12 nautical miles, you can still use the electric drivetrain of an electric ship, but you are probably better off using hydrogen to propel the ferry forward because it has got the highest density in transportation. And here at the bottom, I mentioned also, this is also a commercial opportunity. So someone much smarter than me had a look at the total available market for some of these niche applications and worked out that New Zealand could potentially service a $6.4 billion US market. And just to put this into context, this is also called blue economy. So the blue economy, so that's ocean-related transport, ocean-related tourism, fishing, all ocean-related activities, and it's the 7th biggest economy on the planet. So it has got the economic output of California. Just to put it into context, New Zealand is the 52nd economy on the planet. So, and at the moment, New Zealand is not really participating a lot in this area. That's what we're trying to change. And I want to talk about the ocean, Te Moana, and climate change. So this is a very short summary of the IPCC report. So it's really simplifying things. But basically what it says is we are seeing the highest carbon concentrations in the last 2 million years. We're seeing the fastest sea level rise rates in the last 3,000 years. We're seeing the lowest level in Arctic sea ice for the last 1,000 years. And I've just looked at a video from Fox Glacier from Victoria University. I can strongly recommend you watching that. Over the last 20 years, that glacier has shrunk, I think, by a third. So there's a lot of not so good stuff happening, and the more we know about it, and I think satellite-based remote sensing can help a lot. Just to put this into context a little bit, since the beginning of the last century, the sea surface temperature has risen by 1.5 degrees. The ocean acidity has increased since the 1800s by a substantial amount, and that to a degree is responsible for some of the coral bleaching and other impacts we're seeing in the ocean. Because even though the ocean is the biggest single carbon sink on the planet, well, what that means is the more CO2 you put into the ocean, the more acidic it gets. So on the one hand, you're solving a problem, but on the other hand, you're creating a problem. And then sea level rise is about 20 centimeters since last century. And the ocean, as I said before, is a big carbon sink. And on average, it sequesters 25 gram per square meter. And I could talk a little bit about that. You probably have heard about a paper released in the last month that the Gulf Stream is slowing down. And I don't know how much you know about oceanography, but essentially the Gulf Stream is driven by density differences. And it's called a thermohaline current. And there are others like the Kuroshio, the Brazil current, and others around the world, but the Gulf Stream is the one lots of people talk about. And it's a huge carrier of heat across the ocean, and in particular the UK and Central Europe is very much dependent on that heat pump to keep going. And I just got images from a good friend of mine in the middle of Germany. And 3 days ago, they had hail bombs about this size coming down. And basically, they were sitting in a swimming pool. There's summer over there. And the whole area was flooded with hail bombs. So we're seeing severe weather events happening more and more often. And in my hometown, my sister's house, which is in the middle of our little town where we have a river, which is normally about the wide is my hands, basically flooded the whole town. It's a 36,000 population town, and pretty much everything was underwater, and her cellar, which is about 2.5 meters deep under the ground, was all flooded. And another town not far from my hometown basically got completely demolished, and I think over 100 people died. And it's in summer in Europe. So there's a bit of stuff happening, but there's also some good news. So coming back to the carbon sequestration potential of the ocean. So the ocean can do about 25 gram per carbon per square meter per year. But if you look at salt marshes, mangroves, and seagrass, they can do a multiple of it. So there's a really interesting potential to look at coastal or near shore ability to sequester carbon. And I don't want to overlabor the point, and we share these slides anyhow, but it's a big multiple of a carbon sequestration possible in salt marshes, mangroves, and in particular seagrass. And if you have traveled in New Zealand recently, a lot of developers are now developing salt marshes into flash hotels and other things. And I do think, given the precarity of our carbon situation, I think it's really worthwhile looking at how we can protect some of these areas and make sure that we don't take them away. And I mean, again, an example here from Northland, we have here the Hikurangi swamp, which over the last, I think 80 years, Kevin, you can correct me, please, has been dried up for farming. And that was one of the biggest natural swamp areas we had in Northland. So humans are doing a fairly efficient job in destroying some of the things which can actually save us. So I do think, again, coming back to the link to satellite imagery, the more data we can collect on these things, and the more we ground truth it with on-ground measurements, the better we can guide policymakers and farmers and other people who care about the environment to actually do something about it. In New Zealand, there's a it is very important, the relationship between Maori and water. So a good friend of mine, Milan Ruka, here on the right, is one of the persons who's representing iwi on the rewriting of the Resource Management Act, so that we protect our waterways better. And the program is called Te Mana o Te Wai. And again, there will be links to the proposed policy changes in terms of how to look after our waterways. And I mean, it's simple things that cows are not supposed to trample the eels on the side of rivers. They should be fenced in. They shouldn't their feces and things into riverways, because about 40% of rivers in Northland are not deemed wadable. That's even worse than not swimmable. And I come from Germany, which is about the same geographical area to New Zealand, but all our rivers, including the Rhine, which is the biggest river in Europe, is swimmable. So if one of the biggest industrialized countries can sort out their waterways, I'm sure New Zealand could do that too. And it's not a 20-year plan, it's something you can do fairly swiftly. And again, that's something where remote sensing can help, where you can see where the areas are which are most affected. In terms of climate change, I mean, we always point the fingers at someone else. It's someone else's problems. I totally disagree. It's everyone's problem. And individual people can do something about it. We can save water, we can save energy, rather than taking our SUV to get our kids to school, because 40% of our traffic is educational. So it's mom and dads dropping kids off and kids taking the big car going to university. If we stop doing that, 40% of our carbon footprint is coming through transport. So if we start changing our behavior, we can already make an impact. 40% of our food gets thrown away. So again, if we only buy what we eat, or potentially even grow stuff in season and just consume stuff which is in season rather than strawberries all year round, we can already make an impact. If every third person is doing something like this, then we're gonna be able to make a big impact. And then one of the things we as an organization do is we go into schools, because we actually think behavioral change is easiest if you get kids convinced, and then the kids convince mom and dad convince grandparents, or the kids convince grandparents, and then all of a sudden you get a halo effect. So that's the families, and then families group together, and communities, or in Maori it's hapu, and then cities, regions, and countries. And I mean, here in Whangarei, about almost 2 years ago, we declared a climate change emergency as the Whangarei District Council. We have done spreadsheets and everything, but we haven't done any, in my opinion, meaningful action. Rather than having 150 things we could do, we should have done 3 things, get them done, and then get the next 3 things done. So there's an interesting approach. And New Zealand as a country declared a climate change emergency, I think in October last year. And again, there's very little action. We currently actually providing input into the emission reduction plan, which New Zealand Cabinet has to sign off by the end of the year. So again, if we have more scientific data we can provide to policymakers, so that's local council, regional council, and central government, then hopefully we can start making a difference. And it needs to be top down, so that's prime minister down, but also kids up, if you like. So it needs to be coming from both sides, and we can't delegate this. Climate change mitigation can't be delegated. It's something we all need to do. So why do we think the blue ocean economy is important for New Zealand, and why now? Is, first of all, look at this really cool projection. So it's called the Spillhouse projection, and it firmly puts New Zealand into the center of the southern hemisphere rather than sort of a fringe thing. And here on the left side, you see sort of New Zealand lighting up. So we have 15,000 kilometers of coastline. I mentioned that Germany, which has 20 times the population of New Zealand, has got about 600 kilometers of coastline. So it's a completely different ball game. We have the 9th biggest exclusive economic zone on the planet. So that's 200 sea miles out of the continental shelf of New Zealand. So that comes with a stewardship or a responsibility to look after the ocean. And again, the area is so massive, we can't really monitor that ocean base. It needs to be also monitored from space, and we really need help on that. I think I talked about it. In terms of potential, I talked about the gigawatts of power from the ocean. I mean, every 12 hours, tide comes in, tide comes out. 4,000 years ago, the Aztecs and the Egyptians could predict tides to about 15 minutes accuracy. So it's nothing new, really. I mean, we're knowing this for a very long time, but it has been much easier to produce energy from first burning stuff. I mean, burning trees. Now we're burning oil and gas. I think there's a better way to power things. And New Zealand has also got other advantages. And the biggest advantage, in my opinion, is talent. I mean, we are a land of navigators. Pretty much all of us who are here somehow made the trip here, either by plane, by boat, or something. The Maori, 800 plus years ago, came in their walkers here. We just won the America's Cup this year. We just won a silver medal by the same guys at the Olympics. So we actually do know a little bit about the ocean. And not only that, we also know how to harness ocean power. I mean, anyone who sails and who understands that at 10 knots of wind, you can go at 40 knots with a ship. That's pretty amazing stuff. And again, that kind of technology can be used to harness some of the power of the ocean. So even though we're a small country, we believe that it's time for us to play a bigger role in this area. I'm a fan of Sir Paul Callahan. I don't know if any of you know him. I was very fortunate to have met him. He was a physicist at Big University, and he had this idea that New Zealand should shift from doing the cheapest primary produce, i.e. milk powder or firewood or forestry, as we say it here. We should shift to use our brains and develop something like Weta Digital, that we do movies, that we do IT stuff like Zero, like Vents, that kind of stuff, that we use more our 800 grams of software we have in our head. And by doing that, we also offset some of our carbon footprint. New Zealand has got, I think, the 5th biggest per capita carbon produced per capita per year. So we're some of the dirtiest people on the planet. And we think we clean, green, and all dandy. It's not all dandy. As I said before, 40% of our rivers aren't deemed swimmable. And we have the highest car ownership on the planet in the OECD, which I guess is the richer countries. But it's not all bad. I mean, if we turn things around, and we firmly believe as an ocean-based nation that some of the answers may be in the ocean. That's job creation, climate change mitigation, and sort of some of the things listed up here. I'm not sure how I'm doing time-wise. Don't want to go over the allocated time slot.
Yeah, I think maybe if you can wrap up in a few minutes.
Yeah. Okay, so this is an interesting graph where someone put together sort of ocean-based contributions to greenhouse gas reduction. So 21% of what we need to reduce our greenhouse gases can come from ocean resources. So that's energy from the ocean, ocean-based transport, so that we clean up the fuel we're using. That's the coastal and marine ecosystem. So that's some of the sequestration I talked about. That's food production. And so there's huge potential in the ocean. We actually think that the stars are aligning. We have a political environment, unlike Australia, which actually understands that climate change is an issue. We met with the climate change minister about a month ago, and he totally gets it, and asked us to provide input into the emission reduction plan. So there's political will. There is lots of green investment happening at the moment, probably at the highest rate ever. And technology has improved dramatically. So we do think now is the time to do something. And sequestration of carbon is potentially a revenue opportunity, as well as doing something good for the planet. So I don't want to bore you with some of our natural advantages and the technologies, but what if we don't do anything? I think this is really important that we think about this, because if we don't act now, we will have more of these happening, more droughts in Northland, more flooding on the West Coast, more flooding in Otago. I mean, these are images from Northland from this year and a few years back. And we're very close to Antarctica. So this is an interesting graph on sea level rise. And I have been very fortunate to have been in Antarctica. And there's a very big ice shelf at the moment, the Thwaites ice shelf on which is already seeing some degradation. So if that would start moving into the Antarctic circumpolar current, which is the fastest current on the planet, which distributes anything in its way into all three oceans, into the Atlantic Ocean, Indian Ocean, Pacific Ocean, that if that ice shelf moves off, that in itself could bring a massive sea level rise. And of course, the garbage patch in the South Pacific, you probably have heard of that as well, is also something which is probably not very nice. So there's a lot of things happening at the moment, and the key thing really is we need some innovation to address these things. And I mean, this is really a pitch for schools we're trying to do, so apologies if I put sort of not you as adult innovators there, but I actually truly believe that sometimes people who haven't been brainwashed and all their creativity educated out of them probably may come up with some really cool ideas which we haven't thought about, and ultimately it's their future. So, and here's an example of a few people who have actually done a lot of cool stuff in New Zealand. I mean, we were the first to split the atom. We were the first to give voting rights to women. We were the first to get onto the highest mountain on the planet. Lots of people didn't know, but Jean Batten was one of the first aviators. We sent rockets into space. We do little chip things. We win races. We do a lot of really cool stuff. Why not some of this? So we actually need you. So I've finished on this one. Thank you very much.
Thank you so much, Martin. Let's see, I will go back to stop sharing. No, great. Yeah. Thanks so much for the presentation. So before we go to potentially questions and discussion, let me just do a short recap on the mechanics of the challenge, just so for the recording. And just go here. So yeah, so again, the challenge, as Eric mentioned, there's like two categories. There's a high school category and a university startup category. The requirements are pretty simple. You basically need to be a high school or a university student or a startup, and we define startup pretty broadly. Any organization or group that is like has less than 20 people, and you're a resident of New Zealand, Australia, and the Pacific Islands. The prize, again, with the two levels, it's 30,000 New Zealand dollars in cash for university and startups, and then 10,000 for the high school. Both have 15,000 equivalent of data vouchers and also a mentorship for 6 months from Spacebase. And for the high school level, they also get a scholarship to the US-based Mars Moon Virtual Astronautics Academy program. Essentially, what's happening is that we are running a virtual incubator between November and January, of which anybody who participates in the incubator will have webinar sessions, access to specific satellite data from Planet, and then also mentorship. That, as I mentioned, will happen between November to January. And to be able to participate in that, you essentially need to submit an initial proposal that is open now until the 31st of October. And that proposal really is very simple. Again, it's only 2 to 10 pages, which includes, for one, the background of your team, and then the specific aspect of the problem that you're actually addressing. So, I mean, carbon sequestration is pretty broad. So we need to understand which particular area you're focusing on. The general technical approach. So, what is the technology that you would want to leverage? Is it just space? Is it a combination? We also need to know what your project plan and schedule is, just a draft of what you would want to do within the time period. And then specific requests for technical support. So what kind of data you're thinking of? What are the tools maybe a data analysis platform that you kind of like need. And then the real actual application, the final application is, the deadline is the 31st of January. And the requirements are, it's really just, it's a 5-minute video demonstrating what you've actually accomplished with the solution or your prototype, and then a presentation deck of your solution, which you'll probably use for the final pitch and demo session if you make it to the 6 finalists for the 18th of February. So we'll be down selecting 3 finalists from the university startups and 3 finalists from the high school. Also to note that you don't need to be in the incubator to actually submit a final application, as long as you submit the final application by the 31st of January. And actually, that's it for me. So let me just like stop share, and we have a few minutes for people to ask some questions. Actually, I do have one for Martin. When you showed your slide of sequestration, which include salt marshes and mangroves and seagrass, how much of that, like today, currently is mapped? Like for example, as an example for New Zealand, how much do we know where those are at the moment? And is that an opportunity, for example, for satellite data?
It's a really good question. I wouldn't know. I would not know. But I do work with a guy who basically came up with some of those numbers, and I think it has been mapped partially for Northland, but I don't know how it has been mapped for the rest of the country. So I definitely think that would be a really good exercise.
Yeah. Yeah, because if we can equate, like with the map, if we can equate the and quantify the number of CO2 that's being sequestered from the map, then that's kind of like one example of a potential focus area that a team can actually work on.
And it's interesting that there's some overlap between the carbon sequestration, and the Allen Coral Atlas actually has a category where they identify seagrass in the Pacific region.
Oh, okay.
But they don't. The Allen Coral Atlas only covers like down to the northern part of Australia. It doesn't reach the latitudes of New Zealand, basically.
Right?
Mm-hmm. Yeah, but I would like to think that it will be a really good exercise to do that for Australia and some of the Pacific Islands as well.
Yeah.
Because, I mean, again, even though we're a little speck in the ocean, and just because the wind blows all our pollution away, it does not mean that there isn't any. So, and most of the islands are diesel economies. So there's a lot of pollution happening in the islands to just keep the lights on.
Yeah. A lot of your comments about energy from the ocean really apply to, would be fantastic solutions for Pacific Islands. Yeah, to move them away from. Yeah.
From fossil fuel.
Guys, I have a question.
Yeah.
Hi, Martin. Thank you. So you touched on in one of your slides, blue energy and ocean observation, the buoys, as a technique to measure the ocean. Is that data available from anywhere?
So you mean some of the in situ measurements?
Yes.
Yeah. So some data is available. For example, the Northland Regional Council annually publishes sort of their data. I think the Hauraki Gulf in Auckland has got a lot of data on the state of the Hauraki Gulf. So that's water quality, temperature, sort of all sorts of key parameters. So I do think there is, I think all the regional councils in New Zealand have got an obligation to report on water quality, and some do it better than others. I mean, for example, in the Kaipara Harbour, which is the biggest harbour in the Southern Hemisphere, we have one measurement unit, which we think is ridiculous. And we think that satellite and other other cheaper options can complement that. So for example, this little buoy I was showing is probably going to cost less than $1,000, and the technology they're currently using is $50,000 for one measurement thing, which doesn't even send the data in real time to the cloud. So this little buoy basically pops around and generates enough energy to do the measurements, and then every 15 minutes sends it into the cloud. So hopefully soon there will be more data available, but any ideas on how to complement that will be great, because the government is spending $300 million on cleaning up the Kaipara Harbour, and to find out what to clean up, you need to do a benchmark first, in my opinion.
Yeah, so it's very much regionally based, so that data would have to be abstracted individually from each council.
But potentially, but I think it would be really good to have a conversation with Moritz from Sarah. So that's the Alexandria-based outfit, which is working with some satellite data. And I think he looks at freshwater quality. So he probably has got a comprehensive data set for the whole of New Zealand.
Okay.
So I think his name is Moritz Lehmann, and I can provide the contact details.
Okay.
Yeah, and Jess is the same organization as Duncan Steele, who gave the presentation during the opening.
Mm-hmm. Oh, right. Okay. Yeah, no more questions from me, but thank you, Martin.
No worries. Where are you based?
I'm based in Auckland.
Oh, okay. Okay. Wow.
Yeah, so not far from you.
Yeah. I mean, the Hauraki Gulf study, if that's some of interest, that's probably the most comprehensive study on water quality and sort of preserving our maritime environment.
Okay. Okay.
Great.
Thank you.
Hey, one question. With thinking about the mangrove salt marshes, etc., is there historic data, satellite imagery that could be used?
There are both the Sentinel data goes back a number of years, and also the Landsat data. And so I don't know if anyone has ever tried figuring out exactly how the coastal environment, how you can identify the different features in those data sets. That's the planet data only goes back about
2014 and 2019, I think, is there.
Yeah, so it's a handful of years is for the higher resolution data, but the spectral data from the other satellites, like Landsat has a 30 years history or more, and so
but the resolution is
a very low resolution. So that's an interesting question. That's a potentially a valuable question exercise because a lot of the carbon sequestration reporting is very focused on 1989, 1990 timeframe, because that was sort of like from the Kyoto protocols, for accounting for and things like that. And so the older data on these systems is very important for a lot of the accounting systems.
Right. Okay. Good.
You mentioned that the Coral Atlas has got some data on seagrass. How does it technically work? Because I saw a paper that other people using satellite data for seagrass detection and tracking.
Yeah, so they the Allen Coral Atlas is, it's an interesting process, and it needs they're always looking for more verification and validation, but they basically have about 6 intensely studied regions around the world that they use to train their machine learning data, and then they apply this across the board for all the different regions in the around the world, and including lots of in the Pacific. And so so they have these automatically generated classifications for these different regions, but they would love for people to validate locally what their maps are, but they so it's a combination of not only do they use the imagery, but they also use some data on the depth and depth of water in the coastal areas, and use that to also adjust for their classification.
But it's all planet data.
Yeah, it's based on planet data. They have basically processed data from 3 years, three layers of the planet data, all with atmospheric corrections and cloud removal, and even corrections to enhance looking through the water. And so but it does boil back down to those 6 calibration sites. And so
Well, where do you have a paper on that where I could read up?
The Allen Coral Atlas does have a very detailed reference
resources
library.
Actually. So if you go on the
Sweet.
Allen Coral Atlas website, it's got lots of resources on there.
Yeah, to explain exactly where they're looking and for all these things.
And also the maps as well.
Because I guess if you want to cross correlate with real data, you need to take the data at the same time, not 6 years later.
Yeah, not 6 years later. That's right.
So it's important to get the synchronization.
Yeah, and even even at the high school level, using the Allen Coral Atlas, those teams will also have access to new planet data. And so you can say, okay, if something changed at a certain time, you can look at the planet data and see what has changed, and they're very interested in those interactions between, especially with flooding events, or they have they monitor specific events with coastal with bleaching and things like that.
Because it would be really cool if you could see the salt marshes and mangroves as well. That's land-based stuff. So I'm not sure how easy it is, and what the spectral, I don't know, footprint would be to be able to detect that. Yeah.
So we're looking for teams that look at this data and map the extended mangrove forest. That would be a strong entry into our challenge. And so so that's because you're right that the coastal areas and this blue carbon is a tremendous factor in carbon sequestration. That's at the same scale, if not, or potentially much larger than some of the land efforts. So,
Great.
Yeah.
Well, I think we've probably we're at the end of our time. Any last questions, if there's any? No. Okay. Well, again, thank you so much, Martin, for your presentation, and then also for those who have come and participated, and Jess and Kevin. Thanks for coming as well. And we'll definitely we'll upload the recording on the website as well. And we're going to be sharing this also on social media as well, and as a resource for all of the applicants.
And if people have watching this later have questions, please send us
either at info@spaceforearth.org or challenge@spaceforearth.org. Great.
Excellent.
Thank you so much.
Thank you very much. Thanks for having us.
Thank you.
Bye-bye.
Excellent. Thank you very much.
Bye.
Bye.